Let the model to RC conversions begin. Today I'll show you how to assemble this 3D printable 1/25th scale RC truck chassis. Hello everyone and welcome back. After some design work, testing, and tuning that I've showcased in the prior parts of this series, it's finally time to release the first batch of STL files. My goals for today's video are to showcase everything that's included in this first batch of files, what's still a work in progress, what you can expect to see posted in the next batch, and of course show you how to put this chassis together. If you're new to this series, I highly recommend you check out the playlist linked below in the description and check out the prior videos. In those videos, I introduce this project, go into more detail about the design, and list the goals I have for this chassis. To give a brief summary though, this chassis, which we've called the CTC-01, is simple in design, easy to 3D print, and easy to assemble, providing a great base for converting 1/24th and 1/25th scale model truck kits like this one into fully functioning RC vehicles. So without any further introduction, let's go ahead and talk about what's included in this first batch of files. Before we dive into the build, I want to go over what we've included in this first batch of files. First, I think it's important to point out that this chassis design is still at least somewhat a work in progress. While I'd say the design is overall pretty well polished, and there's certainly potential here to build an awesome truck, I expect we'll find areas that can be improved over time and updated in future versions. Right now there aren't a lot of optional parts or variants available, but you can expect to see additional parts being added over time, such as a motor mount design for larger N50 size motors, single rear axle variants, different wheel designs, and additional wheelbase and width options. At the time of this video's release, files for the fifth wheel have not yet been posted, as I'm still tinkering with that design, but it shouldn't be too much longer before those files get added. Be sure to stay tuned for more information about the parts designed for trailers. Of course, we look forward to seeing what you all build and hearing your ideas and feedback on the design as we gradually work to incorporate new parts, features, improvements, and variations. My knowledge and experience with 1/24th and 1/25th scale truck models is pretty limited, so it's hard to say for certain what kits will work best. You may need to tweak a few things, such as spacing out the wheels slightly to fit a wider 1/24th scale truck, or create custom body mounts to attach the model to the chassis. Hopefully in the future, I'll have a better idea of the variety of kits that are available, and we'll have more options to make mounting them to this chassis as easy as possible. Despite the chassis still being in its early stages, there's tons of potential for a very fun build, and it's probably fair to point out that you don't exactly need a huge budget to build one of these chassis, as it's designed around common, off-the-shelf parts and inexpensive hardware. I have stated this before, and it maybe goes without saying, but this is really a project best suited for more experienced RC and model building hobbyists. While the assembly process of this chassis should be pretty simple and straightforward, especially if I do a good job with this video, any project involving 3D printing your own parts, sourcing your own hardware, and fitting a body not specifically designed to be an RC vehicle will present some challenges. Custom work will be required to adapt the plastic model kit to work with this RC chassis. This video will only cover the assembly process of the CTC-01. However, stay tuned for a full build video where I modify a 1/25th scale GMC General plastic model to fit on top of the chassis. Of course, unless you're using the exact same model kit and building your truck the exact same way as I did, that build video might not be something you can necessarily follow along step by step, but hopefully it will at least give you some ideas and inspiration. A pretty basic assortment of tools, including some small size screwdrivers, hex drivers, and a wheel wrench will be used to put this chassis together. Tools I would assume anyone who's done any kind of work on an RC vehicle will have on hand. One tool though that I definitely recommend getting if you don't already have one is a pin vise hand drill like this one. These are so handy for enlarging holes on 3D printed parts or on model kits. If you find a hole to be a little too small, you can clean it up or enlarge it with the drill. Very easy, and it comes in handy on a lot of these projects, especially on these smaller 3D printed parts. Also keep in mind that you will need to solder the wires to the motors, so make sure you have soldering equipment. Be sure to take your time during the assembly process, and as always, if you have any questions, feel free to send us a message. Every part of the CTC-01 is designed to be easily printed on a typical hobby FDM or FFF type 3D printer. Just for reference, every part that you see here I printed using a Creality K1. Again though, just about any typical hobby 3D printer should do just fine, as long as it has a build platform large enough to print parts that are 160mm in length, and I recommend using a 0.4 or smaller size nozzle. Supports will likely be necessary on a few parts, but most of them have a nice flat bottom and minimal overhangs. Precise settings will vary from printer to printer. However, as with any other project, I highly recommend taking the time to ensure your printer is producing parts that are the best quality you can, and double check to ensure the parts are dimensionally accurate. A good build starts with good parts. So let's start by putting together the rear section of the chassis. As you'll see, this is a very simple design, and it should be quite easy to assemble. However, there are a few little tricks and things that you should know, which I'll be bringing up along the way. You'll find all of the STL files for the rear of the chassis in a specific folder. I've gone ahead and printed one of each STL file in that folder, except for the N20 motor mounts, which I've printed 2 of. With this current chassis, there's only one configuration, and that's a non-powered steer axle in the front and 2 drive axles in the rear. A pretty common setup that you'll see on a lot of semi-truck tractors, but in the future I could definitely see us creating some additional variations, maybe some that just have 1 axle in the rear or maybe even more than 2. We'll put together a parts list with links over on Patreon, but I want to quickly go over some of the parts that you'll need that can't be 3D printed. You're going to need 2 of these dual shaft N20 motor and gear assemblies, both with identical specs. You'll also need 4 of these N20 couplers. Now these are just a standard off-the-shelf item, which are inexpensive and easy to find. You just need to make sure that you get the 2mm hole on the one end, as they are available in multiple sizes. To make a long story short, I may consider designing some wheels that have a larger diameter axle in the future. These 2mm rods are easy to cut, and I've used them on a lot of prior projects. However, I do see some advantages with possibly moving up to a slightly larger diameter axle. Of course, you will need some 2mm steel rods like this one, which is what you'll use to secure the wheel to the coupler. This here is an M2 thread, but a regular round rod would probably work just as well. I do like having the ability to thread the wheel into place rather than just solely relying on the glue. Honestly though, on a model like this, it probably doesn't make a big difference either way. I think the best and cheapest option would be to purchase a longer length such as this, and then just cut 4 individual pieces that you can use for each of the rear wheels. I think the only alternative to cutting your own shafts would be to order some 2mm dowel pins that are the length you need, assuming you can find them. We should be able to have the measurements listed on Patreon, but really the exact length is not that critical, as it just needs to be long enough to extend inside so that the set screw can hold it in place. If you find the track width is a bit too narrow for the body you'd like to use, you can always just throw on some washers or something else to act as a spacer to move those wheels out further. Basically, all the parts that you see here go together with M1.6 hardware, with the exception of this M3 fastener. This will get used to secure the motor mount pieces to the frame and allow them to pivot, which will give you some suspension. I will try to specify what hardware goes where, especially when the exact size is critical, but we do have some diagrams showing what piece of hardware goes where, so definitely reference that as needed. Obviously, there's a lot of threading into plastic, so whether you have a coarse or fine thread, it really doesn't matter on a lot of these parts. If you find any of the openings to be too small, a little pin vise hand drill like this will really come in handy. What we'll need to do first is secure these N20 motor and gear assemblies to these parts here. We'll start by removing one of these screws on the side, as we'll be replacing it with a slightly longer screw, which will go in through this hole here and help secure the motor in place. The motor should be a snug fit. If you need to, you can take a hobby file like this and sand down some of the inner edges of the part if needed, but you really don't want much play between the motor and this 3D printed part. Just slide the motor in and line up the hole, then use a M1.6x3 machine screw, which should thread right in. Now it is important here that you don't use too long of a screw, as it can come into contact with the output shaft on the motor and not allow it to spin. This shouldn't be an issue if you're using the same size screw as I have here, but if when you get everything wired up and test out your motors, you notice one or both of them are not spinning, make sure that the screw is not interfering with the rotation of the motor. Start backing out this fastener, see if the motor starts to spin. If it does, you'll know it's too long. Both of the motors are solidly attached to the mounts. So we can go ahead and install the 4 couplers with the larger 3mm diameter holes sliding over the output shafts on the gearbox, and then we can tighten the set screw to secure them in place. You'll need to go ahead and get these motors soldered together. It's not like they're drawing a ton of power, so a single ESC and a 3S LiPo should be just fine. Just make sure that you solder the motors together like I have here. All you have to do is create a little junction on the positive and negative wires so it can feed both motors. You'll need to wire one of the motors as normal, positive to positive, negative to negative, but you'll need to do the opposite on the other motor. That way they'll rotate together, driving the truck forward and backwards rather than trying to separate from each other. Of course, if you do run into a situation where the motors are trying to pull apart, just swap 2 wires. It would definitely be a good idea to test that now, assuming you have all of your electronics ready before moving any further with putting the chassis together. The ESC I'm using has a JST RCY connector, which will plug right into this socket. Of course, make sure you don't exceed the maximum voltage that the motors are rated for. These here are 12-volt motors, which I've been powering with a 3S LiPo. So these drivetrain, axle, motor assemblies, whatever you want to call them, are complete. We can go ahead and use some M1.6 hardware to secure the frame rails to the cross members, and this piece here, which the 5th wheel will be mounted to. It's mostly just M1.6x6 hardware, except for a few holes on the cross members where you can use longer M1.6x8. As I talked about earlier, to mount the wheels, what we'll do is cut a section of this 2mm steel rod, which we can use to secure the wheels to these couplers. You'll probably notice that there's 2 different variations of the rear wheels with different backspacing. Obviously this one, where it extends further out, will go on the sides, where the coupler is closer to the center of the chassis, and then these other 2 will go on the opposite corners. Now on these wheels here, that fit closer to the coupler, there is a cutout. That way you can fit your tool in there and easily access the set screw. Because of this, you might find it easier to install the tires after you install these wheels. With that said though, at least with the tires I've used so far, they're soft enough that you can just push them out of the way if you need to tighten or loosen that set screw. Whatever works, I just thought I'd point that out. I'm going to go ahead and cut the steel rod using a Dremel into 4 individual sections, which I can thread and glue to the wheels, and then to secure the wheels to the couplers, I'll use the set screws. To connect the axles to the frame, we're going to use a M3 fastener and a lock nut. When you're putting them in, make sure that these parts here align with the holes on each side of the frame. The bolt should slide right through, and you want to make sure that the axles can move up and down. Make sure not to over tighten this nut. You want it to be tight enough so there isn't a bunch of play, but also loose enough so that the axles can move without too much resistance. I'm going to go ahead and put a zip tie around these wires just to tidy them up. On top of each motor mount, there's a couple of 3mm diameter holes, which you can place a spring into for the suspension. To prevent the axles from dropping down too far, put a M1.6x6 screw on each side. This rear section of the chassis is now complete, so we can move on to the front. Now we can go ahead and assemble the front half of the chassis. Just like with the rear section of the chassis earlier, all of the parts for the front are located in a separate folder. You'll need to print one of each part in that folder, except for the leaf spring, upper coil spring mount, and upper knuckle mount. You'll need 2 of those parts. And then the shackle pieces, make sure you print 4 of those. We can start by putting together the front axle. I'll screw an M2 by 18 bolt into each one of the steering knuckles. Be sure that the orientation is the same that I have here, with this lip being on the same side as the threads. I'm going to add some glue to this bolt before tightening it all the way so it doesn't move. Using 4 2x5x2mm bearings and 4 M1.6x8 screws, we'll sandwich the knuckles into place as shown. Be sure to pay close attention to the orientation that you see here, with both of your knuckles facing the same direction. Also note the orientation of the knuckles here. You want this part to be closest to the bottom of the axle. You don't want to flip them around. Once again, using M1.6x8 screws, we can secure the leaf springs to the axle. You should notice that there's a little arrow on each of the leaf springs. Make sure those are pointing in the same direction as this part here of the knuckle. We can go ahead and connect the steering center link to the knuckles, once again using M1.6x8 fasteners. A nut will be used on the bottom to hold everything together. I haven't been able to find any M1.6 nylon lock nuts, so unless you can find some in that size, you'll either need to use glue or Loctite to make sure the nuts don't come loose. Again, pay close attention to the orientation that you see here. When viewing it from this angle, this hole is off towards the left. And then hopefully you'll notice there's a little cutout right here, and that should be facing the bottom. Make sure you don't over-tighten those nuts, since we want the steering to move smoothly and with minimal resistance. I'll go ahead and get the micro steering servo that I'll be using for this project. Like everything else, I'll have a link over on Patreon. A lot like on our FPUC1 chassis, I'll be modifying one of the arms included with the servo. I'll be drilling a 1.6mm hole on one end of the arm and cutting off the opposite. After modifying the servo arm, we can connect the drag link with a small O-ring placed in between, and then use another M1.6x8 machine screw and nut to hold everything together, just like I have here. Using the same fasteners and O-ring, we can connect this assembly to the center link. We can set this axle aside for now and start working on the frame pieces. So the orientation of these parts that you see here is very important. I'll do my best to show you how it all goes together. A couple of things to keep in mind is when you're looking at the frame rail like this, the third hole back should always be towards the ground. And then also this flat edge here of the front leaf mounts need to be facing towards the front of the chassis. I'll start putting these parts together and show you how they should look. We'll have some illustrations and hardware diagrams that should hopefully help as well. I'll start with this left side frame rail. I'm going to use two M1.6x16 screws to secure everything together. But as you'll see, I'm not going to drive these in all the way just yet. Like I said, I'm not going to drive these screws in all the way just yet. In just a minute, I'll be screwing those into this piece right here. And once these parts are connected, that's what will hold the front of the chassis together. Hopefully your frame pieces look like the ones I have here. Next, we can go ahead and install these upper coil spring mount pieces using two M2x6 screws on each side. Make sure they're attached to the outer edge of the frame rail, just as you see here. Next, using M2x14 bolts and lock nuts, we'll install the upper half of each shackle onto the frame, just as shown. Make sure that this thicker side here is what goes up against the frame. Make sure not to over-tighten the lock nut so the shackles can move with minimal resistance. Next, I'll go ahead and install the steering servo. Make sure that when you're looking at the chassis from the front, the spline is on the right. You can just slide this side in and then use a M2x6 fastener to secure the opposite side. Now that the servo is positioned between the two frame rails, I can drive these screws in all the way. At this point, you can go ahead and connect the other end of these frame pieces to the cross member. Using some more M2x14 bolts and lock nuts, we can secure the leaf springs to the chassis. Just like with the shackles earlier, make sure you don't over-tighten the nuts so the suspension can move smoothly. If you want, you can place a coil spring in this section right here if you want some additional support for the suspension. After powering on the electronics and centering the steering servo, you can attach the arm. Be sure to set the endpoints so the servo is not overextending. Both of the front wheels use 2 bearings each, which you can press into place on both the front and back. Just slide the wheel on to the threaded axle, and then use a M2 nylon lock nut to hold the wheel in place. You want it tight enough so there isn't a bunch of play, but loose enough so the wheel can spin freely. With the front wheels in place, that pretty much covers the assembly process of this 3D printed chassis. As showcased and talked about in a prior video, optional electronics and body mounts are available, which can be secured to the frame rails using M1.6 hardware. Additional crossmember and frame pieces can also be added to extend the wheelbase. From here though, you can continue by getting the electronics and body mounted. I certainly hope you found this video helpful, and I want to wish you the best of luck with your project. Of course, if you have any questions, please don't hesitate to send us a message. If you're a member on Patreon, I'd recommend contacting us there. We'll do our best to respond as quickly as possible, especially with the release of these files. We want to assist the best we can, and we can always come back later and address some of the questions in the form of a post or video if a specific question is being asked over and over. Stay tuned for more parts, updates, and to see me build a GMC General using the CTC-01 chassis. I'm very excited to be able to finally share these STL files with all of you, and of course I appreciate everyone's interest and patience throughout the development of this new chassis design. These videos and STL files are in huge part thanks to the support of our hundreds and counting supporters on Patreon. A huge thanks to all of you for your support and continued interest in these rather unique RC projects and chassis designs. As mentioned, there is a complete non-3D printable parts and hardware list over on Patreon. While that list should be very helpful to any builders out there, I understand it isn't exactly the most convenient or cost-effective to have to order a bunch of parts from different sellers. So right now we are working to put together a hardware and non-3D printable parts kit, just like we have for our other chassis designs. That way all you'll have to do is print all of the STL files, buy a single kit that will have every piece of hardware that you need, and then add your own model kit, battery, and radio. We also plan to sell some kits with everything already printed for those who don't have access to a 3D printer, but not until the design is more finalized. If these kinds of projects are of interest to you, make sure you're subscribed to this channel and stay tuned for more videos coming soon. Until then though, as always, thank you all very much for watching, and I'll see you next time.